This is, excuse me, a damn fine cup of coffee.
Yo, what is up? Check, check. How's it sound? Let me know if the music is too loud. All right.
I'm gonna let you in on a little secret.
We look live. Sweet. So,
Give yourself a present.
today, I'm gonna do something I don't normally do. I guess kind of a technical deep dive here up front, and then we're gonna do some live coding. Going to implement Zaps into my PlebDevs platform that I'm currently building right now. But first and foremost, I want to take at least 30 minutes, maybe 45 minutes, and I want to see how deep of a dive we can get into Hedgehog and how much I can understand it. My friend and protege, SuperTestNet, wherever he is in the world, he released Hedgehog. Was this yesterday, March 26th? Was that yesterday? Wow. Yeah, I can't believe that was yesterday. I feel like everyone has been talking about this the last 24 hours. It seems like lots of discussions, lots of things coming out, new revelations, but I'm still getting caught up from absolute zero here. So I want to watch Super's video, and then we're gonna look into his repo here, and I'm going to try and break down basically how a hedgehog works into my own kind of document that I can follow. There's a lot of information here, so we'll see how deep into this we can get, but in a way it seems simple. Seems like there's two big concepts to understand here, but yeah, I mean, let's get into it. And definitely, if you are familiar with Hedgehog in the chat, feel free to call me out. If you know something I don't know, and you know, definitely not a technical expert here, just a pleb dev, but I think we can get a basic idea of what's going on here. So let's, I'm gonna mute the music here and let's start to dive into the video. And let's see what this is about. So I'm trying to keep the volume here. Be careful because there's a lot of background noise.
Hey guys, this is SuperTestNet, and today I just wanted to show you my latest invention, which is called Hedgehog. Hedgehog is a protocol for asynchronous layer 2 Bitcoin payments. So these are kind of like the Lightning Network. This is a protocol similar to the Lightning Network in that it's a layer 2 for Bitcoin payments, only in this one, unlike the Lightning Network, the two parties don't have to both be online. It's asynchronous. One party can send the other party money when they're offline, or when the second party is offline. So I'm going to show you how it works, and to do that...
okay, so first of all, I guess just from how he's framing it, how I'm going to frame this and how I'm going to think about this is that it seems like the goal here is to create a protocol as close as possible to how Lightning works, sticking to those fundamentals, but with a focus here on async payments, which I guess by his definition means being able to receive offline, which currently with Lightning, I mean, I guess the big difficulty, the big barrier to entry is the fact that you need this always online server. And this is a problem with so many things in Bitcoin, is the need for an always online server. So it seems like that's what he's trying to solve here with Hedgehog.
I'm going to show you first, and then I'll tell you a little bit about it. So if I'm going to follow the instructions that are on the screen here, enter Bob's pub key and revocation hash, which I do like that. And then it says to do the same thing over here. It says send some sats to this address and give the TX ID. To do that, I'm going to use MutinyNet, their faucet.
Okay, so it seems like this is like the channel creation process. So they're establishing a multi-sig together, and then someone's going to fund it. I guess Bob.
I'm going to send 10,000 sats into this Bitcoin address. This is a multi-sig between the two parties. Okay, so I did it, and then it wants the TX ID. So the TX ID is this. So I'll put that in there. It says what vout is it in? Well, let me go check. It happens to be vout 0. So I'll go back here. I say vout 0, and the amount was 10,000 cents. Same thing over here. Just say 0, 10,000 cents. And now this is Alice over here. Alice wants information from Bob. So Bob's going to send her this little piece of information down here. It's okay, and great, the channel is funded. So Alice, before money went into this multisig, Alice should get this from Bob, which allows her to take the money out if she wants to. And now that the money is in there, well, I can show you how they send the money back and forth. So I do hedgehog Alice send, and it asks, it says, Alice, you've got 10,000 cents. How many do you want to send to Bob? Let's say she wants to do, I don't know, 6,000. So basically, it creates this little script in here. Not script. It creates this little piece of text that has a payment for Bob in it, and I can do hedgehog Bob receive. Enter that. And the new balance is, Alice has 4,000 cents, Bob has 6,000 cents. And they can keep doing this all day long. Like, Bob did not have to be online. She could have sent him this in an email, and he could have come online later to type it in. But let's just do one more, hedgehog.bob send. He will send back Alice, I don't know, 3,000 cents. So he copies that, and we do hedgehog Alice receive. Just like that. Now the new balance is Alice has 7,000 sats, Bob has 3,000, and at any time either player can close this channel. They can be like, it's all in a multisig, so they could cooperatively close by just co-signing to send the money according to the latest state. But there's also force closures. So if I do hedgehog.alice close, this is like a unilateral exit by Alice. So it broadcasts a pair of transactions. One of them is right here. And let me go broadcast this one on MutinyNet. So.
Okay, so we see the funding of the channel from one side, so it seems like some of those concepts are crossing over already. We've got a funding of a channel from one side, and it started, I think was it Alice? So Alice funded the channel, so she had the full balance, and then we had a state update, I guess 2 payments that went back and forth, which switched the balance, which updated the state. So I guess that's kind of like, we have the happy path open, we have the happy path of them being able to send to each other. And then I guess the unique thing there is that there's this string that's actually being sent, which has, I guess, the state update and the revocation script in it, which basically means like, okay, here's the updated state where you now have 3,000 more sats, and here's the script, the updated script to be able to, I guess, force close or unilaterally exit, as he's talking about. So I think that kind of makes sense so far. Let's keep going.
mutinynet.com/tx/push. This is their transaction broadcaster. You can broadcast that. And Alice has initiated a closure of this channel in the latest state. And so the latest state, well, she puts most of the money into another multisig between the two of them, and a little dust output over here. And she's going to spend both of those after some blocks go by. So her channel closure transaction, her finalization, is right here. And if she tries to broadcast this, it won't work right away because, this says non-BIP 68 final. There's a time lock on this. In case this isn't the latest state, Bob has an opportunity. Bob has some time wherein for a few blocks he has got the ability to show that this is not the latest state, that she updated it to some new one. And so while we wait for the
Okay, so that's interesting. So it seems like, so Alice is initiating a force close, and she's saying, okay, here's the latest state, but just like on Lightning with the classic revocation, the other party, if they discover that state is bad or wrong, they can prove it, and they should have a revocation script, which is basically, they call it revocation, justice transaction, punishment transaction sometimes, but it's basically just the idea of the, like, if Alice gets caught cheating, broadcasting a state of like, oh yeah, Bob paid me all of his sats. Like, if that's not a true state, then if Bob can prove that and then actually take all of Alice's funds. So that's kind of the, I guess, the process to like keep each other honest. Like, you know, this is how I kind of think of a Lightning channel as well. It's like two people are coming to an agreement. They're in a contractual agreement in this multi-sig, but they also have guns pointed at each other. At any point, if any of them broadcast bad state or tries to cheat each other, they can pull the trigger and then take all the funds, which is a really cool mechanism. So it seems like that same mechanism is at play here, but I imagine it's being done differently. Okay, so now, okay, yeah, and then also that's happening in this time lock. So Alice wants to close her channel, but she can't just close it instantly with the bad state. There's this time lock that she has to wait for, and during that time lock is when Bob has the opportunity to revocate, if the state is wrong. Okay, let's keep going.
Those blocks to go by. The transaction this thing currently has 2 confirmations. I've got it to where it needs 5. But while it's waiting for those confirmations, I can tell you a little bit how this works. This uses something that I invented, I think I invented this, called a revocable connector. And I got the idea for revocable connectors from Barack, who invented connectors, and from Lightning, which invented revocation scripts. Or Lightning probably didn't invent revocation scripts, but they're used in Lightning, and that's where I learned about them. So basically, a revocation script looks like something like this. Alice can spend the money after some amount of blocks, or Bob can spend the money if he knows Alice's secret. Right? If Bob learns a certain secret created by Alice, he can just spend the money. So that's a revocable script. We use them in Lightning to make sure that, like, this is how Lightning penalty works. If you send a Lightning payment that's not the latest, then your counterparty can steal from you, not steal, but like do a justice transaction and take the money in the channel because they know the secret that you gave them when you revoked your old state. So that's used in Lightning, and it's also used in Hedgehog. But then,
okay, so that's a good mental model, and that's a good little visual he had there. Back up. Oops.
the other
If I back up just a hair, yeah, right here. So this or statement here. So basically, what we have is every state update. So Alice updates the state. She passes the secret over every time there's a state update. And the same thing with Bob. And so the secret is basically the right to rug each other. Rug isn't the right term here, but the right to revocate if the other party is dishonest. So, okay, that's pretty simple idea. Revocable scripts. Okay.
revoked your old state. So that's used in Lightning, and it's also used in Hedgehog. But then the other thing we use is connector outputs, which were invented by Barack. And they allow, if you've got some money in a multi-sig, like we do here, a connector allows you to say, hey, I'm going to send some money from Alice to Bob, but it only goes through if a certain UTXO exists, because that UTXO is used as an input to the transaction. And this makes it so that you can't create UTXO-B unless UTXO-A exists, because the transaction allowing you to do it consumes UTXO-A as an input. So our 5 blocks have gone by, so I can now finalize this state. So this says non-BIP68 final, but now it works. So I have dispersed the funds. And so if we look at this transaction here, it shows this one. It sends the funds, 7,000 go to Alice and 2,000 go to Bob. It's supposed to be 3,000, but Bob has to pay the fees here. He was the last person to send, and the last person to send pays the fees. So there were 500 sats to make this transaction happen, which is the parent, and then another 500 sats right here to make this transaction happen. So Bob paid the fee.
Is that the case in Lightning? I don't know if that's the case. I'm trying to think. Like, I think in Lightning, it's just whoever initiates the close is the one that pays the fees because you're the one broadcasting the transaction. So that seems a little bit different here. He's saying that the final party to do a state update is the one that pays the transaction fee. That's kind of interesting. I wonder if there's like maybe an attack surface there where you can be hostile and like have the other person pay the fee. I don't know. Digging too deep here, but that's interesting.
And thus Alice gets 2,000 and Bob gets 3,000 minus, fees, a couple of transaction fees. But yeah, this is like an off-chain payment protocol, and two parties can go back and forth sending the money to each other, and it's just as fast as the Lightning Network, but it's different because you only need one party to be online, and that's great. That's cool. So I'm calling this protocol Hedgehog, and there's an implementation of it on my GitHub that you can test out, and it's really neat. Go check it out. Thanks. Talk to you later.
All right. Very cool, super. Let's look at this README now, and I'm gonna pull out my my ChatGPT here to help me summarize this. Do I want to write anything down? Let's just take a peek at this first. Okay, so. Hedgehog works. Hedgehog is built on a primitive Bitcoin script called revocable connectors. To make revocable connectors, you need two even more primitive primitives, revocable scripts, and connector outputs. Okay, which is what he talked about in the video. So let's see if we can get our head around these two primitives. So we talked about the revocable script. So AS is Alice's secret. A value Alice may reveal to Bob if she wants to revoke her ability to safely receive money in an address containing the top script, BS. Is a similar secret Bob may reveal to Alice to revoke the bottom script. Okay, and I guess by bottom script here, we just mean the latest state update. I believe so. So, okay, that makes sense. Connector outputs. A connector is a primitive Baroque popularized by using an ARC. Suppose you have a multi-sig address like this. Shout out to Baroque. True story about Baroque. The first time I met him, I asked him something like what do you do? Like, what do you do for work? And he just told me, he's like, oh, I'm a dark wizard. And I was like, oh, okay. So that's the kind of hacker that Baroque is. He doesn't even call himself a dev. He's just like, oh, I'm just a dark wizard. Okay, connector outputs. So suppose you have a multi-sig address like this. We've got Alice and Bob. So Bob can create a signature that sends money from that address to Alice. But since signatures can commit to multiple inputs, he can make his signature conditional. The SIG is only valid for a transaction that also consumes a second input. That second input is called a connector because it connects UTXO-A to UTXO-B. Alice can only spend UTXO-B, a UTXO locked to the above multisig, if UTXO-A exists because it is used as an input to the transaction Bob signed. This evokes a similar idea to me of like child pays for parent, maybe, where we have like, what would you call it? I guess a packet or package of transactions here where can only spend UTXO-B if UTXO exists. So you have this payment UTXO-B and you're making it conditional by the existence of UTXO because B consumes A. Okay, that kind of makes sense, but I don't know how this comes together. So combining them, hedgehog channels. This is a lot. This is deep right here. Okay, with these two primitives in hand, suppose Alice opens a channel with Bob by sending 10,000 sats into a standard multisig. Okay, so Alice opens to Bob with 10,000 sats. Alice can send Bob 2,000 sats off chain while Bob is offline. Okay, we saw that in the demo by sending him two signatures. The first signature is valid for a transaction that A creates a 330 sat dust UTXO revocable by Bob. The dust UTXO is locked to the revocable script. And B sends the change, 9,670 sats, minus a fee, so more like 9,500 sats, back to the multisig Alice and Bob. Okay. The second signature is valid for a transaction that sends 7,000 sats to Bob from the multisig, and the UTXO locked to the revocable script. So the second transaction input contains 9,500 plus 303 together, and the UTXO locked to the revocable scripts serves as a revocable connector. The second transaction sends 2,000 sats to Bob, and the rest, 7,830 sats minus a fee, back to Alice. I felt like I was following there at the beginning. Okay, so Alice's new off-chain balance, 7,500 sats, down 2,000 with sats and a fee. Bob's new off-chain balance, 2,000 sats, up 2,000 sats. This is state 2. State 1 was just Alice with 10,000 sats and Bob with 0 sats. Okay. When Bob eventually gets online, he can accept Alice's disbursement, state 2, like this, cosign and broadcast the first transaction, which creates the revocable UTXO. Wait 2016 blocks for the time lock on the revocable UTXO to expire, then cosign and broadcast the second transaction. But there's a better option. Bob can keep the signatures on hand and wait because he might want to send money back to Alice later. And there's no reason to close this channel yet. Okay, I see. So this is just like a single state update, and then Bob can just close the channel from there and accept that, that single state update. But he can also not broadcast those and keep the channel open to then update that state once again. Okay, I still want to... Okay, let's get ChatGPT here. Okay, so I'm going to copy this. Can you help summarize this passage in the new spec proposal? Oops, don't do that. Stop. Okay, so this is the passage, and then I'll just send, this is the entire spec proposal. I'll just copy this. Okay. The example given involves Alice and Bob, with Alice initiating a channel by depositing 10,000 sats into a multisig. Alice can then send Bob 2,000 sats off-chain by creating a transaction that includes a revocable connector, a 330 sat dust UTXO, revocable by Bob, and sending the remaining balance back to the multisig. A second transaction from Alice to Bob finalizes this off-chain payment. Bob, when online, can accept this transaction or wait to reciprocate with his transaction, maintaining this channel's flexibility. Final considerations. Okay, explain. Explain the revocable connector concept. Like I'm 5. Okay, imagine you and your friends have a box of crayon. You both promise not to take crayons out of the box without asking each other first. One day you decide to give your friend 2 crayons while they're asleep so they can use them when they wake up, but you want to make sure you're doing it fairly, so you come up with a clever plan. Oh man, I need, not like I'm 5, okay, like I'm 15. That's piggy bank. Okay. So we have the piggy bank. We both need to agree every time you want to take money out or put money in. Now let's spice it up with a replicable connector. Let's say you want to give your friend $20 as a gift, but you won't see them until next week. Instead of handing them the cash directly, you write them a check. This is like the connector. But there's a twist. This check has a special rule where if you change your mind, maybe you need the money back for something else, you can revoke or cancel the check before they try to cash it, as long as you do it within a certain time frame. Okay, so this is a time lock. So this is like, I see. So this is like I can make a state update and send to Bob offline. He can claim it at any time, and it seems like publish it on chain and basically close the channel. Or Alice, before Bob claims it, has a second transaction where she can claw it back. So you give your friend this special check. They know they can cash it next week, but there's also this period where you could cancel it if you needed to. This is useful because it allows you to make a promise about paying your friend, but also keeps you safe in case something comes up you need the money back. I don't know about this explanation so far. The system is special check, replicable connectors, helps make the transaction more flexible. Okay. I use ChatGPT like this. Yeah. Yeah, it's pretty useful. Sometimes you just need things in different words. I don't know about these words, but it's good to break it down. So I'm still not fully understanding the structure of this revocable connector, but I get the idea of the connectors, and I get the idea of the revocable script. Okay. I'm going to try and read this one more time. So Alice opens a channel by sending in 10,000 sats. Alice can send Bob 2,000 sats off chain by sending him 2 signatures. The first signature is valid for a transaction that creates our dust UTXO and sends the change minus a fee back to the multisig. The second signature is valid for 7,000 sats to Bob from the multisig, and the UTXO locked to the replicable script. Since 2,000 sats to Bob, and the rest minus a fee go to Alice. Need super testnet GPT. That's $1 million idea right there. Super testnet probably if he if we could get his secret scripts and train an LLM on them, it'd be very powerful. He has a lot of, from what I hear, from what he's told me, a lot of secret Bitcoin scripts and projects. So that'd be pretty good. Okay, so I'm getting the high level idea. It seems that this concept of connectors, this is what allows the condition. The condition of having the transaction that you can claw back, but also the transaction that the other party can claim as basically the state update. So both parties are basically they're baking a state update and they send it over. And that state update also includes the revocation that the other party can make if the state is wrong. Okay. So it's a pretty good introduction there. I feel like I need a second pass at this, specifically the revocable connectors. But pretty cool. It seems like this seems simple, and this seems to have almost all of the same concepts that we see in Lightning, and a lot of the same mental models that apply as well. There's a lot of conversation here on Stacker News. I haven't gotten to read through all of it, but definitely I saw Justin from Shocknet. Where was that? Yeah. is kind of questioning him here, like basically what is the difference between this and like an LNURL withdraw? Since the receiver must come online to sweep the state, it's not asynchronous. It's a promise, not unlike any centralized solution. The internet does not work asynchronously. It works through reattempts and resignaling. So it's kind of an argument of terms. Super here compares it to a check. If I was at a grocery store, I gave the clerk a check. Then later someone asked me, but did you pay them? I would say yes. And instead of a bank account, these checks are redeemed from a multisig where the recipient is a key holder and can enforce the redemption. That's my point. Language matters. Are LNURL withdraws an async payment? Does Lightning have async payments already? If the answer to either of those is no, then the same is true of Hedgehog. I see. Yes, they are async payments when you have to trust someone's word until you redeem it. LNURL, but they require trusting a server until you redeem them. Hedgehog fixes this. I see. So it is kind of an argument of semantics a little bit. I see the point here. Like, there's a lot of schemes that you can have for creating async payments, and like I even created a very, very basic dumb spec for this myself using Nostr Wallet Connect, where it's like, oh well, I can pay someone if they're not online with Nostr Wallet Connect, and it's kind of like, well, that's not true. Really, what I can do is I can send a payment that they can claim to a server via Nostr Wallet Connect, right? So I can kind of bake this payment with Nostr Wallet Connect. I can have it sit on the server, and then once they come online, they can claim it. So then, in a sense, it's like, well, I'm sending you a payment when you're offline, but it's not actually async, and you do have this server in the middle that's trusted, and then you end up back to square one, where it's like, well, now I have a server again, and I'm trying to figure out how to make my server not be a trusted party in this. And there's different things you can do. Make it easy to run the server, make the server open source, et cetera, et cetera. But yeah, I guess Super's argument here is like, there need not be a server. Like, the transaction isn't sitting on a server. It's this piece of information. It's this script and this transaction that you can broadcast as the other party. It doesn't really require a server. Like, you can text this to me, you can email it to me, and then like I can claim it or revocate. And there need not be a trusted server in there necessarily. So I guess that's kind of the nuance here, but man, this is fascinating. Yeah, I mean, there's been all these discussions about L2s, and there's a lot of new L2s coming out. I mean, it's cool that Super, in the time when there's like so many L2s coming out, Super can drop his own L2 proposal, and then it gets a lot of people excited, and it's surprisingly simple. So that's cool. But yeah, I mean, definitely like a lot of what I've been thinking about with L2s as this discussion has escalated is it's just like, what are these primitives that we need for scaling payments on Bitcoin, right? And something that's important in there is that ability to unilaterally exit back on chain. And so this checks the box there. You can unilaterally exit back on chain. So that's an important one. And then there's like the concept that we're sort of sharing a UTXO. And so, I mean, in a sense, Lightning is kind of the only L2, and I guess Hedgehog here, where we have a UTXO sharing type of scheme where either party still is sovereign in the sense that they can unilaterally exit back on chain, assuming they have enough sats that they're above the dust limit. And so this seems like the trade-off that a lot of people are coming around, and similar to ARC. Like, the whole idea with ARC is that you have this VTXO, and this VTXO is this state that you can trade and exchange between. You can pay Lightning invoices and receive Lightning invoices, and you can exchange with other people inside of ARC, exchanging these VTXOs, and all of that's off chain. But the whole time, your share of this VTXO, you can unilaterally exit and kind of split your share in your latest state off of that, and then hit the chain with your own UTXO. And so, yeah, I guess I see a lot of these ideas. They're very, very similar, and we're just trying to figure out like what is the best way to give you, the full kind of sovereign control as if you have a UTXO on chain. But then we have we remove all the friction, allowing these, infinite state updates and infinite payments back and forth like Lightning within channel. But yeah, fascinating proposal. Definitely going to look into this more in the future, and I'm still not fully satisfied with my understanding of the revocable connectors, but the primitives here are at least pretty easy to understand, very similar to Lightning, very similar mental model Lightning, so that's awesome. But all right, cool. Shout out to Super. And now I'm probably just gonna get into some live coding. Yeah, like I said, I mean, if you know about Hedgehog already, you know more, like, call me out. If you have any questions, throw them out there. But let me update my notes here. So we tried to understand Hedgehog. Did pretty good. Okay. Let's hop over to some live coding now. And I'm gonna need to start up Docker. Sweet, so we spent like 45 minutes on that, not bad. 38 minutes. Sweet, so I am working on the new PlebDevs platform, which is not quite live yet. I've been working on it for about 2 weeks now. I'm very excited about how it's coming along. Definitely still have a lot of features I want to add, but I'm in a fun point now where a lot of the front end stuff is taken care of, and I can start to implement more of the fun sort of Nostr features. So I'm going to start with Zaps. This evening, very simply, just want the ability to zap a piece of content first and foremost. And then from there, I want to show how many zaps are on the pieces of content. So let's spin this up. I'll give you kind of a quick up-build. Give you a quick tour of the app so far. It'll take a second to spin up here. I'm using Next.js here for the front end, and I have a database with Prisma and Postgres. This has been my favorite stack to work with as of lately, and a lot of the reason is just like it's very similar to Stacker News, and a lot of other projects I've worked on recently as well. So it's a good tool set, and I'm getting more familiar with it. Okay, localhost. Let's check it out. Cool. All right, so here's the basic landing page we have right now, and kind of the basic site. Hopefully this gives an idea of like how I'm trying to frame the website. So this is there's a lot of things I want to do beyond the MVP, but the basic MVP for this is just I want to be able to host all of my content in one place, and I want to be able to host it on an open protocol, aka Nostr. So right now, all of this content is just open and free, and these are actually example resources I'm just posting for like, basically just filler data for right now, but it will look something like this. And so the idea is that this is all free content right now, but the idea is that I'm gonna post, a majority of my content will be free here. The courses will probably be paid. And I'm kind of coming up with a scheme to have it to where all the content, no matter what, it's going to be broadcasted to Nostr, but the paid content, you're basically going to get the offer of like, here's the image, here's the title, here's the summary, but the content of it is going to be encrypted. And for the time being, I'm just going to use like an app key pair on PlebDevs, so you'll kind of be trusting PlebDevs at first to encrypt the content and keep the keys to decrypt it. So it's going to be centralized in the sense that like you come into this website to pay for the content. and to access the paid content. But all the content is still spread, and it's all on Nostr. And so as you post from here, you'll be able to go over other Nostr clients and see that your content is there as well. So, you can be posting content free or paid, and people that have never even been to this client will be finding it on other clients, will be able to interact with it and zap it and stuff like that. So that's kind of the idea. So it's just the main page. I've got 3 content types I'm going to be starting with. A resource, which is basically going to be a document, workshop, which is going to be a YouTube video with kind of a summary, and then a course, which we're still early on this. It's not in its full schema, but a course is, I think how I'm going to do courses is actually a lister. It's going to be a lister of individual resources, basically individual documents that all come together in a certain order. So I think lister will be able to solve that for me, but not quite to that point yet. Yeah, so I have a basic details page for when you visit the content. And I have my Zap button set aside right now. And you have a profile over here, so I'm logged in as myself, so that's why there's both PlebDevs icons here. And a lot of this stuff is boilerplate. It's not all there. But basically the idea is like you're going to be able to create these resources. I've got these forms to do it, and as soon as you create them, they're going to live as drafts. So they're not actually going to be posted in Nostr first. And from the point that they're a draft, you can go visit it, and then you're going to be able to publish it or like edit it. So that's pretty cool. And since all of these pieces of content, I'm not sure about listers, but the workshops and the resources are both the long form NIP23 content. So that means they're going to be editable, which means that they call it parameterized replaceable events. It's just basically this idea in Nostr that you have a special parameter that if you provide with an updated signature, that the relays will take the old note and no longer show it and only show the updated note. So it's not like you're actually editing the original note. It's more that it's just, I guess, a part of the spec that relays recognize and will only serve up the newest piece of content. So effectively, from a client standpoint, it's a way to make events that are editable. Cool. Yeah, so that's kind of a basic overview. So open up the inspector here, and yeah, we're going to start on the details page here. I'm just going to start with this Zap button. So I have this set aside, so let's jump into the code here. And I'm on the latest. Okay, cool. So right now, most of the Nostr logic lives inside of here. I have this pretty large hook to use all the Nostr logic. It's not completely cleaned up, but I just have a bunch of functions here for pulling in content. So I have specific functions for fetching my resources, where I have various criteria to determine, what is my resource and like what do I want to show on the website. So that's definitely deep topic right there. Fetching kind 0, fetching single event, publishing event. Yeah, and then I have like a relay statuses thing to keep up with the statuses of my relay or relay connections. Cool. So I'm going to start with Nostr tools, because this is going to be the library I'm using. And I know they have a NIP57 module here. And so NIP57, I have it pulled up here. This is the spec for Lightning Zaps. It is one of the biggest NIPs, as far as I know. There's a lot in here. It's a lot to read through, even the protocol flow here. But essentially how this works is it's built on top of LNURL pay, that is. So essentially how this works is we're going to pull, so we're going to get the user from the piece of content, or get the author. We are going to, I'm going to write this down actually. Figure out where I'm going to put my, so zaps. So we are going to, we are going to get the author, the content. 2, get the authors, 0. 3, get the author's LUD16 if available. So that LUD16, that's going to be the Lightning address, basically. So I guess, yeah, it's not LNURL pay. It's actually LUD16, which is Lightning address. And so that should be on their profile, but not everyone has one, right? So we need to make sure if it's there. So after we have the LUD16, no, not that. We are going to make a request to the LUD16 endpoint. With a zap request Noster event. Okay, that's where I need to look at the spec. So I believe I know we create a zap request event, special kind of Noster event. And I believe we actually send that to their LUD16 endpoint. So let's go here to the spec and make sure. So grabbing the LUD16 field. Okay, the client must send a GET request to this URL and parse the response if allow Noster exists and it's true. Oh, yes. So that's an important thing as well we need. So get the author's LUD16. So actually, first we need to make a GET request to the LUD16 endpoint and ensure that allow Noster is true. Cool. Okay, and if Noster pub key exists and is a valid BIP340 public key in hex. The client associate this information with the user along with the response, callback, min symbol, and max symbol values. Okay, that's just the traditional callback fields. Clients may choose to display a Lightning Zap button for each post on a user's profile. Okay, why are you telling me this first? When the sender indicates they want to send a Zap to another user, the client should create a Zap request event as described in Appendix A of this NIP and sign it. Okay. So next we create a Zap request event and sign it. Instead of publishing the Zap request, the 9734 event, I think that's the kind, should be instead sent to the callback URL received from the LNURL pay endpoint for the recipient using a GET request. See Appendix B for details. Okay, so we do call the callback with the event. Appendix B. And this shows how we do that. A lot of steps here. Arian says hi. Hello. What is up? Welcome. Okay, so we send to the callback. Send to the callback URL as a GET request with the Noster event as a query param. Cool. Noster query parameter. Okay. If the Zap request is valid, the server should fetch a description hash invoice where the description is the Zap request note, and this note only. No additional LNURL metadata is included in the description. This will be returned to the response according to LUD06. On receiving the invoice, fetch a description hash invoice. Okay. That was confusing. I was like, why are they fetching a description hash? So that's just a part of the verification step in LUD16. Because you basically bake this the invoice with a special description hash that comes from the info on the LUD16. I know it's confusing, but we go over this in the YouTube PlebDevs check out the PlebDevs Lightning address workshop. That's somewhere here. Here it is. No, that's Lightning login. Lightning address, we go over all of this. And there's also the LN URL pay, which is kind of a prerequisite to that. Okay. Back to our flow. So on receiving the invoice, the client may pay it or pass it to an app that can pay the invoice. Send the callback URLs, get requests on our server. 7, get the invoice back and pay it with WebLN. I'm just going to use WebLN for right now. There will be probably more options for Lightning payments later on. So we pay it. Once the invoice is paid, the recipient's LN URL server must generate a ZAP receipt as described in Appendix E and publish it to the relays specified in the ZAP request. Clients may fetch the ZAP receipt in posts and profiles, but must authorize their validity as described in Appendix F. Non-empty comment. Okay. So basically, 8, listen for the ZAP receipt. And update the UI. Yeah, sure. Okay, so that's kind of our spec here. That's a lot. That's 8 steps. Let's start to break this down. So I know I'm going to have so there's some helper functions here that I want to try and use from Nostr tools. We have get zap endpoint, make zap request, profile event, amount, relays, comment, validate zap request, make zap receipt. I'm not the one making a zap receipt. I'll be listening for zap receipt. Okay, so these look pretty useful. So let's try and just build this in a one function at first, and we'll see how we can split it up. So I'm going to say const zap event equals async. Okay, so we're going to take in the event. Let's see. Yeah, we'll just take in the whole event. And so first we're going to get the author from the content. So, you know, actually, is there a different consideration here for in the spec for zapping an event versus zapping a user? So this is a zap request. Now, next pub key of the recipient. E is an optional hex encoded event ID. Clients must include this if zapping an event rather than a person. Okay. So we have the P tag for zapping an individual and an E tag. Do we need both? It doesn't really explicitly say that. In the zap spec, when making a zap request to an event, not a pub key, do I need to only include E tag? Oops, forgot to provide the spec. Rather than a pub key, you should include the E tag. Okay, so we just exclusively use the E tag only. According to ChatGPT, we will find out if I am trusting too much. Okay, so we're going to say const author pub key equals event.pubkey. Actually, I don't even need to do that. I'm just going to do, so I have a fetch kind 0 function here. And I'm already using it, so fetch kind 0, let's see how I'm using it. Okay, I'm having to explicitly pass in the filter and the options. That's fine. Turn the music back on. Okay, const kind 0 goes await, fetch kind 0, int.pubkey, kinds, and then no options. So that seems right. And when I'm doing it elsewhere, I think I need to like parse the fields pretty carefully. Kind 0. I have find kind 0 fields here. What does this do? Fields, we have a username property. This is all it's really doing right now, is just parsing out the username property, and the avatar property, so we don't need that. We should have everything we need right away. So const has blood 16 kind 0 if has blood 16. So get the author from the content, get their kind 0, get the author's lead 16 if available. Make a GET request to the lead 16 endpoint and ensure the allow noster is true. Okay, cool. Now this might be where I use noster tools library. So we have a get zap endpoint. How do we use this? Get zap endpoint. Let's check the tests. Return null if neither lead 16, lead or 6, or lead 16 is present. Ah, I forgot. We can have a lead 6 as well, which is a Ellen Euro pay. So what is this? Constant metadata, build event, kind 0 content. Empty. I don't understand this build event from /test helpers. Yep. 57. Go to test utils. I don't know how they're building this event. Test helpers. So params, they pass in partial event. So we're just passing kind 0 empty content. Returns null. Returns null, fetch fails. Returns null if the response does not allow for noster payments. I see. Oh, I see. Okay, okay. Returns the callback URL if the response allows noster payments. So JSON allow noster true, noster pub key, callback. So I'm just passing in the entire kind 0, it appears. So let's try that. So what is that called? Get zap endpoint. Those test helpers. Get zap endpoint. Oh, nip 57. Okay. If kind 0, we'll just say if object. Okay, so if we don't get it, we just error out and return. Otherwise, I'm going to say const zap endpoint equals nip 57. I probably need to await this. Await nip 57 dot get zap endpoint, passing in the kind 0. And then let's just console.log the zap endpoint. And this will be a good point, I think, to actually try this. Passing the event. Okay, let's return zap event. And let's give it a try. We'll plug it into our button. Is this on the details page? I have a button that says zap. Cool. And am I using use noster in here? Got use noster, so I'm gonna bring in zap event. Oops. Okay. Let's make a handler function for this. So const handle zap event. In the entire event. Oh, actually, I have the event here, and we have processed event. So I just want event. And I'm just gonna grab it from the outside scope. So I'll say if not event return otherwise const response equals await zap event, and let's log that. And then we'll throw it on and click on here. Click handles app event. Okay, let's see what happens. See if we get our endpoint. Zap. Ooh, zap endpoint null, zap response undefined. Goddamn. Okay, let's see what happened. So into the use noster hook first. Let's just make sure we got our event. Probably should have checked that up front. So console.log zapping event. Okay, so we have the event. It seems to be in full here. Ooh, I just realized maybe I might have done this from a test account, and my test account might not have a LUT16. So let's check. I can check this with so noster tool is something I use a lot just for doing that quick pub key to inpub. So wait, load pub key from inpub. Sweet. So here's an inpub. I'll copy that, and I can go to noster.com/inpub. Inpub nip05 nip57. Okay. Yeah. So it seems legit. This is my PlebDevs guy, so should have a nip57. Okay. Let me use the bathroom real quick, and then I'll come back and we'll fix this. So I'll be right back. think I realized what dumb mistake I was making when I was gone. Kind 0. Okay, so we're getting the event. Let's check if we're getting the kind 0 back. Log kind 0. Kind 0. I'm awaiting it, so that should be correct. All right, so we do get the kind 0. And there is a LUD 16 field here. Getting zap in point null. Metadata event. Awaiting it. Yeah, I mean, I don't see why this isn't working. Might just do this manually. I promise, I'm awaiting it. Metadata.content. Metadata.content is what's parsing. So I think I am returning the content here, actually. Let's go to fetch kind 0. On event, I'm just pushing the whole event. Oh wait, ooh, I see event.content. Okay, so I don't want to change this function because I'm using this elsewhere, but I can just wrap. I can say kind 0 payload equals, we're just gonna have an object and we're gonna say content is equal to kind 0. Okay, that's kind of backwards, that's kind of funky, but you know, would rather not implement this myself. Let's try it now, see if we get our zap endpoint. Clear this out. Nothing. So content kind 0 payload dot content. So you're getting pass in metadata. It's parsing out metadata dot content, and it's looking for LUD 16 or LUD 06. Kind 0 payload.
Me and Vincent would have been satisfied with some freeze-dried Taster's Choice, right?
Content.
Serious gourmet shit. What flavor is this?
Okay, let's console log this. Object.content, and this content contains LUD 16. So I don't know what is going on. I'm awaiting it. Okay, so screw it. We'll not use this function. We'll do it ourselves. So no kind 0 payload. We'll say so if kind 0 dot LUD 16 else if kind 0 dot LUD 06, this will be the L in your L, and then we'll have else error fetching kind 0. Okay. Show toast. No, it's not user is not enabled noster. This would be error unable to fetch kind 0. Or wait, no. So user has no lightning address or LN URL. Okay, so we'll have handle LN URL pay. I'm just gonna set this aside for right now. We'll just work on the let16. All right, make a get request to let16 endpoint and assure that allow noster is true. So let's console.log this response. See what we get. Yo, what's up? I am working on my personal content platform right here, where I'm gonna host all of my content, a lot of it free, some of it paid. All of it will be tippable and zappable, and all of it's also gonna be completely open on Noster, posted in Noster, stored on Noster. So kind of a weird fusion website where I'm storing all my content on the open protocol of Noster, but I'm kind of keeping a database still to filter which content I'm showing, keep track of who's posting the content, and then also kind of allowing for these to create a paywall and some of these other features. So kind of a fusion Noster client content platform. And I'm working on implementing Zaps right now. So a few steps in here. Okay, let's see if we get this let16 response. I'll clear this out. Oh yeah, go back to details, Zap. Sweet, okay, this is our response. Wow, what a response. What the heck? So we have object.data. So let's console our response.data. Do I need a JSON.parse, I think. JSON.stringify? No, it is stringify. JSON.parse. No. Why is this coming back like this? Oh, I don't just make a request to the kind16. Whoops. Response.data. So actually, const let16 URL equals okay. Let's go to lightningaddress.com. I'm not parsing this correctly. Where's the docs? Okay, so okay. Let16 username equals kind0.split the at. Then let's see domain, same thing for number 1. Okay, that's correct. So we've got username at domain.com. So I'm going to go to domain, well-known LNRLP username. Okay. Const let16 URL equals domain, well-known Noster. It's not Noster. It's LNURLP at let16 username. Okay, there we go. So now let's make a request to this endpoint, let16 URL. Let's see what we get. I've done this so many times, but I still, it's still like something you gotta take step by step. You forget a few steps sometimes. Here we go. This is more of what I was expecting. Let16 response. We see allow Noster, callback. It all looks great. Okay. If response.data.allow noster. Ooh, okay. Okay, Copilot. So if you have that field that is true, we create the zap request event and we sign it. But I'm gonna try and do this with noster tools again, even though it just let me down. With get zap endpoint, we've got make zap request. We've got a profile event. So event is going to be string or null. The profile has to be there. That's interesting. Mount number. So P is profile. So let's see how they use this. Make zap request, throws an error, returns a valid zap request. What is profile supposed to be here? I'm confused. Make zap request. Is there types I can look at? Profile is a string. Event is a string or null. Amount, number, comment, relays. Okay. Const. Wait. Make zap request. Okay, let's just pass in these fields right now. We'll sort them out. So profile is a string, so this will be equal to kind 0 dot author dot pubkey, say event dot pubkey. Event is going to be equal to event dot id. Amount. This is true, we need to pass in an amount. At this point, we need to ask the user what amount they want to send, but we'll hard code this for right now. Say 1,000, because I think this should be in millisats, so 1,000 should actually be 1 sat. So relays is going to be relays. I should have that up here. Relays, yeah. And comment is going to be call it PlebDevs zap. Waiting it. It says await does not affect this type of expression. So let's just console log in. Zap response, line 39. Response.data.allow noster. I think it's just response dot allow noster maybe. Clear. Let's try it again. Too many concurrent requests. this response again. 16 response. So it is .data .allows noster. God damn it. With an S. Okay. That was our dumb mistake. Okay, zap request, and we get the event right here. Array, pub key. We have an E tag. So it's kind of interesting. We have a P tag and an E tag. Can I leave out profile and make a valid one still? Uncaught error profile is not given. Okay. Callback URL equals response.data dot callback. Okay, back to the spec to see how we build this request. So we have callback, amount, start event URL. Actually, do we have a function like this from the library? Make zap request. Event template, event zr.text and pushy, event return zr. Validate. So no, they don't help you broadcast it. Okay, so we'll take this snippet still. So callback URL. Our URI encode this. No. So const zap request. API call. Equals, no, not that. Equals this. Okay, so this will be callback URL. Amount equals zap rec dot amount. We'll hard code this for right now. $1,000 and zap request is the event. What is this ln URL? The recipient's lightning address is encoded as ln URL. Let's see. Const ln URL. ln URL is the ln URL pay URL of the recipient encoded using BEC32. This is recommended but optional. Okay. Just leave that out for right now. So this should be our simple zap request. Alright. Const invoice equals await axios.gib. Console log invoice. Okay, almost through the flow. Should be getting an invoice now. Failed with the code 400. All right. Master, object, object. Okay, so I need to code this. Let's zap request. Do I need to stringify it, I believe? Is an object. Okay. JSON.stringify zap request. Okay, let's see what our request looks like. I miss it here. Here we go. Okay, request header. So amount equals 1,000 and noster full noster event. Response could not generate invoice. Interesting. Why it could not generate invoice? Event.pubkey, event.id. I believe I am the one that posted this, so this should all be correct. Event amount, relays, comment. Okay, back to the spec here. So, oh, encode URI, JSON to stringify. I see. And I need to sign the event. Have I not signed it? No, I haven't signed it yet. Okay. Okay. Sign the event. And I'm going to do this with WebLN. Signed event equals... Oh wait, no. Window.noster dot sign event. Sign event. Zap request. Let's check NIPO7 just to be sure if that's the right function. Sign event, okay. Cool. So signed event. And then we'll do encode URI, JSON to stringify. Signed event. All right, let's give this another whirl. Sorry, relays, if I'm spamming you. Sorry, not sorry. Okay, here we go. Connect. Ah, yes. Okay, invoice. We got the invoice. Invoice is response.data.pr. Okay. Voice response. Say const invoice. Invoice response. Sweet. Not the best looking code so far, but we're working our way through the flow. So now we have the invoice. I'll say else. Yeah, throw an error. Console. Show toast. Okay. Create a Zap request event, sign it, send to the callback URLs, you get request and not query param, get the invoice back and pay it with WebLN, listen for the Zap receipt. Cool. Pay invoice equals pay invoice response. So wait, window.webln.send payment. Okay. Let's see. Pay invoice response. Is there something in NIPO 7 for get public C, sign event, get relays, NIPO 4, NIPO 44? Okay, no. Okay, let's try and pay ourselves. No, error fetching invoice. Error fetching invoice. Oh, it's .pr. Not .invoice, .pr. Okay. Oh, I need to window.webln.enable. Const enabled equals await window.webln.enable. Let's see, there's some condition here, webln.guide that I always get from webln.guide for like enabling and then sending, so getting started. I guess that's just for checking the window. So yeah, I should just be able to enable. It's just console log enabled. I want to see what this says. Okay, it doesn't return anything, but it was enabled, so one sat payment. Let's give it a go. And we get pay invoice response, we get a payment hash, pre-image, very cool, and then our route information. And if I go to Stacker News, I should see that I got zapped. Yeah, one sat from InPub on Note ID. And if I visit this, I see my note. Amazing. Okay, it's awesome. Okay, so we have the zap working. Kind of a happy path, straightforward flow here, but it is working nonetheless, so that's cool. I want to pull in zaps next on a particular resource. So this is going to be on where we render the resource. So how am I going to do this? So let's just go right into the courses carousel. So this is where each course is processed. And so we pull in the list of all the courses. And I'm actually iterating over these twice just to have extra data, but so it'll actually be in the carousel here in the course template where we're gonna wanna pull for each individual course or each individual event we're going to want to basically do a query to see if there's been any zaps on that event and hopefully show it. I don't need this code right here, so I'm actually going to get rid of this. Oh wait, no, I do need that. I don't need this garbage. Don't need that. Don't need that. All right, so course template gets a specific course passed in. And what fields does that course have? This should show us here. We have ID, content, title, summary, image. ID. Okay, so this should be the note ID, or the event ID. So I should be able to, just in here, call my use noster hook and have a fetch zaps. Just do this, use noster. Got zap event, conch fetch zaps for event. Okay, so the filter will be, this time we'll be looking for the zap receipts. That's a zap request. A zap receipt will have a kind number of 9735 and an E tag of our specific event. So 9735, and I need tags here. How do I filter for tags? I'm forgetting. Noster tools. I think there's a filter file. Filter.ts. So I have IDs, kinds, authors, since, limit, search, and then I have this key string value undefined. Okay. Match filters, merge filters. Filter in the Noster tools. Library, can you show me? Value on the E tag. Here's the entire file. Just give it a bunch of context. Hopefully get the right answer quick. And here is the Noster tools. I'm not even sure if this will work because I've found a lot in the past that filtering for tags is sometimes a fool's errand. Okay, so E. Interesting. Hex encoded event ID. Okay, we'll give it a try. Kinds, and then it'll be like this. And this will be event.id. Does this look right? Okay. So, kinds of 9735. Got fetch events, filter, zaps. Where's fetch events? Update data field. Oh, I see. So I need to set aside zaps right here. So it's just figuring out which in this like events use state to populate it. So filter, I pass in the filter, zaps, and then this is a callback function. So this is to check tags actually. So that's pretty interesting. So I could just pass in a function to check the tags, but it looks like it's just doing a callback that returns true. So sweet. Fetch apps or events. Is this it? This might be it. So let's return this app event. And back into our course template. Okay. Bring in use noster. Say const fetch zaps. Noster. Fetch zaps for event. And we'll bring in a use effect. And use state. Say const zaps, set zaps. Fetch apps for event, and do I just need the event ID? Save that. Event.id. Okay, so really this is just event ID. That's all that I'm passing in, event ID. Oops. Events.zaps. All right, let's see if we can pull this zap in. So I'll go to the particular resource. And, oh no, this isn't the carousel, so this is actually here in the template. Refresh, renders the course template, and a bunch of disconnections here. That's okay. We'll fix that in time. Okay. Zap, 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 zaps, coming up empty. Okay, so let's console log inside of fetch events. Make sure we're not just like accidentally parsing these out. So on event console log. If
I don't know what you're talking about, Space Ghost. Go ahead, my show was.
yeah, let's just try that. Get a lot here. Okay. So let's actually say if event.kind is equal to 9735. Then we'll console log it. Keep things moving, keep things grooving. Okay. And nothing. We're not getting any 9735s for that event. So let's check our filter. We're probably doing something dumb. Kinds, 9735, this E tag. Do I want this hashtag here? Like, Filter key of hashtag string. List of strings. Oh, that's a list of strings is the value. I think that's what I'm adding though, yeah. Let's just see if we just make it E. If that changed anything. Okay, it does not seem to. So, in that case, let's simplify our filter here and we'll just say const has required tags. Has E. Okay, so event.sums tagging value. So we have E tag and the value is equal to the event ID. Correct. Turn has E tag value. And pass this filter in has required tags. Cool. It's 9735, right? 57. Zap receipt is only created in the invoice description. Zap request note. And publish it to the relay as declared in the Zap request. Okay. Well, we're close here. It's probably just something with our filter or maybe our relay connections. But we got the zaps working. At least the zapping itself is working. So my goal for next time, I guess, is I want the zaps to show up over here to like the right of the timestamp. Just a simple number with a little lightning bolt. So it didn't get quite there today, but got pretty close. So I'm gonna pick that up next time, and I actually have to get going here in a minute because we've got Austin Bitcoin Design Club tonight here in Austin, so I'm stoked on that. But either way, I guess that was a good walkthrough of implementing zaps here. Hopefully it was somewhat easy to follow. If you want to see this code, you can find it on my GitHub here, Austin Kelsey, and it's called PlebDevs. So feel free to steal all my code. Got MIT license, I think. I don't, but you're good to steal it. I give you my word. Alright, sweet. Well, keep an eye out. I'm going to be doing another stream later this week, potentially this weekend. And I'm preparing the next workshop, which is actually going to be a basic Next.js workshop. So look out for that. And yeah, we'll keep building this and just kind of diving into some cool technical topics on the stream later this week. So thanks for watching if you did. And check out PlebDevs if you want to learn how to code, if you want to build Bitcoin Lightning Nostr apps, or just become a Bitcoin developer. Check out plebdevs.com. And yeah, I'll be back soon.